Hi there, I'm John from CNCKing.com, and today we'll make a custom mild steel lawn ornament. This lawn ornament, or garden ornament, however you want to call it, is made out of mild steel, 12 gauge, which is roughly 3 millimeters or 1/8 inch thick. You can see here, and it's obviously plasma cut. You can tell just from the edge quality, but the obvious thing is it's right next to me here. So this design here is meant to change over time. That's why it's not painted or coated or anything like that. So the longer it's outside, which is obviously until it's completely rusted away, the more it changes. So every season you look at this, every couple of months there'll be something changing here and there, and that's sort of part of the charm of this kind of stuff. So the nice thing about mild steel is that it's very, very hard, and that means especially 12 gauge. So what you do is you put this right into the soil, and you already have this and this here that will hold it up. Or alternatively, if you wanted to, we can weld little spikes on it if you wanted to, or you can actually just put it right on a fence in the background and put a couple ties on it to hold it there. You'll probably notice a couple of things while I plasma cut the owls here. The first thing is you'll notice quite a bit of smoke. What that smoke is actually just the vaporized metal, in this case mild steel 12 gauge, that's left over. So we're maybe vaporizing a 1/16, maybe 1/32. The rest is probably just melted and becomes dross underneath. So there's not that much metal, but metal is a really smoky material, especially stainless steel when we cut a lot of that. And what it's doing now is all the smoke is coming up, but I got an extraction system, so that's why it's sort of disappearing fast, because it's getting sucked down into the table and outside of the shop. Because again, molten steel and steel smoke is probably worse than cigarettes. So what I'm doing here is I'm cutting the inside parts first, and the reason for cutting the inside parts first is because if I cut the outside, there's a chance that this whole thing might move a little bit. And although this doesn't really matter in this case here, it's just a force of habit to try to make things as precise and as accurate as possible for the customer. And as a result, I always do inside parts and then outside parts. Sometimes it actually would be more efficient to go the other way around. In this case here, it might be kind of efficient because I'm not sure it fits perfectly. I tested this out, so I know it fits. But that's the times that you want to do it the other way around. But then you generally have to make a jig so that you have repeatability. In this case here, it's just one, so it's just easier to go with this methodology and cut it out. Now the plasma you'll see is initiated every time it comes up. So when it's going down and it's hitting 125 volts, and then it knows the distance to maintain that as it goes over the top and continues the plasma all the way around as it's cutting now. And of course here you'll see a lot of the smoke buildup, and that's what happens when you're doing the outlines, because it's a continuous plasma and a continuous amount of smoke being generated by the plasma cutter. On my website, I always show a whole bunch of different processes that we use to make metal things. In this case here, we could have done it with a laser, could have done it with a water jet, could have done it with a whole bunch of other stuff, including the router. The reason why I use the plasma for this is there's no very, very fine details. If there's nothing that's really, really small. You know, if this flower would have had a little thing on the inside, which is, you know, maybe 1/8 in circumference, or however you want to put it. If it would have had that, well then obviously water jet or laser would have won. But all the details here are rather large, and they're well within the parameters of plasma cutting. Now, if we did it with the laser produced exactly the same result. The water jet would produce exactly the same result as well. The reason I'm going with water jet is because this is mild steel, so it tends to flash rust really, really fast during production and quickly thereafter. With the plasma, it's a dry process on purpose. I could have gotten a plasma with a water table, but I didn't want that because I wanted a dry process for it. It makes a bit more smoke, but that's why we have the great outdoors. So dry process, cut it out, clean it up a little bit. There's a little bit of dross on the back, but it's very, very minimal. And something you have to keep in mind, you also have dross with water jet and you also have dross with laser. So there's no process that has no dross. Basically what you're doing is you're using high pressure air or gases or what have you, and they're going straight through the material and they're melting it or abrading it on the back side. So what happens is you end up with a little lip. So it doesn't matter the process, it's basically the same result. Now the nice thing about the plasma cutting is that it's really, really fast. It's faster than the laser when it comes to doing this. It's faster than the water jet. So, you know, tomato, tomato, you know, they all have their plus and minus across the board. There's a ton of things that can change those, but that's the way it is. So if you're looking for custom garden or lawn ornaments, contact me at CNCKing.com. We can make them any thickness, any size, any material. So if you wanted this in stainless steel that doesn't rust, we could do that just as well. Contact me at CNCKing.com. We'll make it for you and ship it right to your door.